Okay, question 3, section 8.1. Yesterday we were talking about this generic function y equals ab to the x. Can you identify in the particular equation you see on the left what the a value is? The a value is in front of this part. It is a 1. Creepy weird. What's going on? I would suggest not eating them. Okay, so how about the value of b? 3. Now we said yesterday that the a value represented the y-intercept of the graph. We are going to find out that we're going to be working on some story problems, and in every one of those story problems, this value is going to be the starting amount. Now, we could be starting with a population of people at a college. We could be starting out with an amount of money in a bank account. We could be starting out with a population of bacteria. There's all different sorts. We could be starting out with a medicine. There are different medicines, and we can figure out their shelf life. Do you realize the medicines that you have at your house, whether they're prescription or over the counter, they lose their effectiveness over time. So if they're significantly expired, they're not going to do as much as they would have when they were newer. So that's why they suggest you get rid of old medicines, old medications, and get new stuff. There are nuclear medicines that they use in cancer treatments that have what we call a half-life. In other words, they decrease to half of what they were. Now, they are constantly decreasing. But they say they usually use the term half-life to describe how fast they will be half as effective. And for some of those drugs, we're talking hours. Which means when the pharmacist at the hospital gets that particular medicine ready, it must be administered now. Which is why we have pharmacists at hospitals 24 hours a day. Because sometimes medicines need to be made and administered right away so they can do their job. But there's going to be lots of story problems that have starting amounts. Then over here we have what we call the growth factor. And we talked about that yesterday. And there's two different types. There's the type where it's above 1. And there's a type where it's between 0 and 1. Which case are we in for this situation?
Would it be above 1?
We are above 1, right? So would you call this situation growth or decay? This is definitely exponential growth. If this were a story problem about money, we would be starting with $1, and we would be tripling our money every year. Now, that's fantastic. If you could continue to do that for a long time, you could probably buy your own country. Yes, yeah, if you could continue to do it, I mean, which one of these pictures identifies exponential growth? Remember, we talked about how it never crosses the asymptote, which is y equals 0, commonly referred to on the street as the x-axis. It would be really small on the left side, and it would get really big on the right side. That is choice B. There's your exponential growth. I have some students that draw pictures like this. You tell me what's wrong with this. Oh, they touched the asymptote. Don't do that. Not only did they touch the asymptote, they crossed it and went into the negatives. That ain't happening, folks. That is illegal in every country of the world. Don't do it. Okay? We make sure that we never cross that asymptote. That is your exponential growth right there. You never touch the asymptote. Not the jack asymptote, not the bad asymptote, not even the PHAT, fat asymptote. You don't touch it. Not a single one. Not a single one. I don't know if are there thick ones? I guess it depends on how.
Spell thick though.
Is it C's or Q's? Okay. I told you there's a lot of jokes we can get out of this. Okay? All right, now in this particular question, they are disguising a touch, what's going on. Not dramatically, but a little bit. Okay, so this is really what they're dealing with. And do you know what 4 squared is? 4 times 4 is not 64. 16. I think you were thinking of 4 cubed. You were thinking of 4 cubed. Yeah. All right, now, if that's the question, if that's the equation we're dealing with, would you call this exponential growth or decay? Is this exponential growth or decay?
Exponential growth.
This is super duper exponential growth. You're multiplying your amount of money by 16 times every year. And if this were the formula for the basis of some sort of illness or disease, we'd be in some serious trouble. Okay, that's kind of what they're worried about with the virus that they're dealing with in China, and which is hopefully not spreading too far and wide. Although I know we have the 2 cases in Chicago right now, but hopefully they'll get that stuff figured out. I mean, we all hope that. That is choice C. Thank you very much for the exponential growth vote. Yes. Okay. You mean the graph for A? Or the equation for A? Oh, no, you mean A, the growth factor, or the yes. This is y equals 1 times 16 to the x. She's correct that that y-intercept. Now, why in the world is it really, 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 really hard for me to tell what the y-intercept is of this graph? Why is it really hard for me to tell? Funny. All right. What's the y-scale? It goes all the way up to what? 300. So it's really hard to see the 1 at the bottom, or before you. So we know it's above the x-axis, but it's really hard to see that. Okay. Question 5. You need to look at this equation, and you need to tell me whether you think this is exponential growth or decay. There is one particular number in here that you need to be focused on in order to make your decision. So look at that. Decide which number that you need to focus your attention on. Drives me insane. I can't do it, man. Plus, I don't do a very good job right here. Like, it doesn't grow very well, so I would look horrible. I would look like a bad version of Wolverine. Okay, it's actually had so many units, so it would be white with a square plus something. But it doesn't look anything like
that would flip over and that's dying, right? It doesn't make it speed, it doesn't do anything like that. This is the only one that we use recently. So we want to focus our attention on that 0.73. What do you think that means? I like it.
Okay, what'd you choose? Decay. Which number did you focus your attention on? Which one of those numbers did you pay attention to? The B value, and what is the B value in this case? Looks like a 3, but that's okay. Yeah. Trying to do it without looking at the screen? Okay. Now, I want to talk about this a little bit. You're exactly right. It's 0.73 that you should have focused on, and it is exponential decay. The graph of this would start high, come through the y-axis. Does anybody know the number it would come through the y-axis at? 9. That's true. Right? The y-intercept is 9. We could actually describe this situation as a story problem. And I want to talk to you about a few scenarios where you see this kind of thing happen. Okay? But I need to describe to you how percentages work in terms of growing or shrinking, increasing or decreasing, gains and losses. Everything starts out at 100%. When we talk about percentages, we want to start with 100%. I know that many students think we should start with 0%, but it's not true. We start with 100%. In this particular case, we are going down to 73%. I know it's 73% because it's what the growth factor is. Notice what I did there? I took the decimal point and I moved it over 2 places to the right to convert it into this percentage. Here's my question to you. What percentage did we lose? What percentage did we lose? Okay. If we started at 100% and we dropped to 73%.
Wasn't it like 30?
Well, close. 27%. We dropped 27%. Do you see that? 100% down to 73% is a 27% loss. I know this would be really weird, but if you were at a store and like Kohl's and they said, "Hey, we're having a 27% off sale." Now, nobody's going to pick 27%. Only Menards is dumb enough to come up with a different percentage, like 11%. You know, I mean, I don't know why they do that, but that's their gimmick. The 11% off sale. All right, 27% would be a really weird number for a sale. Okay? But we could think of this as a story problem. I'm at the store and there's a price, an item that I want to buy that started out at $9. And they told me, "Oh, there's 27% off." Now, when you're in middle school, what you do is this. Okay, let's see. I'll take 9 times 0.27. Okay, that's how much I don't have to pay. And now I'm going to go back and subtract that from the $9, and that's what I'll have to pay. That's what you do in middle school. In high school, you can take that 9 and multiply by 0.73 and be done. It's one step, not multiple steps. Now, I understand in middle school they're trying to get you to understand the idea. Same thing's true of taxes. So, you know, sales tax is 7%. You're like, okay, well, figure out how much you're going to have to pay for this item. Okay, well, I take the 9 and I multiply by 0.07, and then I take that number and I add it back to the $9, and that's how much I pay. Yeah, that's what they teach you in middle school. But if we were going up 7%, what percentage would you be at? 107%. Now, if you convert that to a decimal,
would it be 0.07?
Close. What'd you say? 0.07 would be a loss because that number you chose is smaller than 1. We just said that if we add 7%, we would be at 107%. How do you convert that to a decimal?
7.0.
That's really big. I know. What'd you say? That is correct. So you said points. Oh my goodness, you mumbled. If you're going up 7%, it's 107%, and moving the decimal over 2 places would be 1.07. So when I'm at a store and I want to know the item with the tax, I will just multiply by 1.07 and be done. I'm not going to figure out, 0.07 times this and add it back to the original. Now, I hope you understand. Well, let's go to the next question, and maybe we'll get into that discussion. We will here in the future. One of these questions, anyway. Is this one growth or decay? Growth? What number are you focused on? What's the B value here? 4. And that is definitely bigger than 1. So it is exponential growth. What's the y-intercept? The y-intercept is 3. So this would be crossing at 3 and getting big quickly. Yes, you need to be able to make quick sketches of these pictures. These are not, we're not talking drastically difficult. But you do need to know the y-intercept and the basic shape. Okay, now, I see this in SAT and ACT questions all the time. They're trying to trick you here. Lots of you would look at this and say, oh, yeah, I see what you're doing there, Mr. Staley. You got a B value of 1/2, right? And you're like, oh, that's got to be exponential decay. Well, that's not actually correct. Why is it not correct? How are they trying to trick you? There's a flip. If you take that 1/2 and flip it according to the -1 exponent, you get the whole number 2. This was exponential growth. They disguised it to see if you were paying attention. They'll do that kind of thing in different standardized tests to see if you understand what a negative exponent does to the base, because that would definitely change whether you thought it was exponential growth or decay. And what's the y-intercept on this one? It's the number that's sitting right here in front of the 2. It's a 1, thank you. Just remember where it sits and make sure you have that in your notes so you know. You know, if you even wanted to write it 1 times 2 to the x, there wouldn't be anything wrong with that. And I have no idea why 8 is a duplicate question, so we'll skip it. Okay, question 9. If we start with 100% and we go up 30%, now how do I know it's going up? Because they have a positive here, so it is an increase. That's 130%, right? What? Okay, first of all, is that growth or decay? That is definitely growth. What is the growth factor? What is the growth factor?
Would it be like 1.30?
Yes. Move that decimal over 2 places. 1.3. Now, you can write 1.3 or 1.30. I wrote 1.30 just to kind of emphasize that I moved it over 2 places to the left. But if you just wrote 1.3, you'd be fine. Before we go to the next question, what would happen if this were a 5% loss. What percentage would that be if we had a 5% loss?
Every 25%.
If we go from 100 and we drop down 5,
95.
that's 95%. What is the B value that would go with that situation? 0.95, right? Suppose this virus we've got going around our world decides to take 5% of us. Okay? I think they should have named it Thanos. But, that's just me. Because that was his whole philosophy. But, suppose something dramatic happens with this virus and we lose 5% of our population in our world. That's pretty significant, right? To our whole world. Especially for one situation like this. We would use that multiplier right there. I get students who they make their multiplier 0.05. Now listen to me, 0.05. What percentage loss are they telling me? Instead of putting 0.95, they put 0.05. What percentage loss are they thinking? If you go from 100% and they use a 0.05, didn't they just say we went from 100 to 5? What's the drop? 95%. That's worse than Thanos. So they think that there's a 95% loss. If you're working on a problem and you type it in your calculator and let's say there's 100,000 people at a university and in a matter of 5 years we're down to 10 people. Don't you think maybe something's wrong with the growth factor you chose? I mean, even if it's going down, it shouldn't be going down that much, right? So I hope that something, triggers in your mind to say, wait a sec, that's too large of a drop. Maybe I should go back and look at my growth factor again. Those kind of mistakes happen, and I'm hoping we can prevent them. That's the reason I keep drawing this diagram and drawing the arrows and trying to get you to think about 100% and going up or going down. Okay, question 10. You tell me, decide whether that's growth or decay. It looks like it's increasing by 90%. Tell me what the growth factor is.
1 point.
Write it down. Write it down. Write it down. I do like the participation. Write it down. Decide whether it's growth or decay and what the growth factor is. Good job. Choose nice. Good job. Yeah, I know you do. I appreciate that.
Can I use the restroom?
That's what she said. Okay, grab 2 oranges. Go get 2 orange pads. Yeah, you need some new steps. Like we all do. Good job. Growth 1.9. should have been your answer. Growth and 1.9. Growth and 1.9. 1.0, 1.9. We start with 100%. We're going up 90%. That's 190%. And if we move that decimal over 2 places, we get a growth factor of 1.9. And since it's larger than 1, it is definitely growth, not decay. Okay, thank you. 15 minutes. I heard your clock time. All right, now, on question 11. Question 11, I want to do D and E. I want to focus on D and E. Okay? The number of students enrolled at a college is 15,000 and grows 3% each year. Okay? So I want to, on letter D, I want to come up with the equation. So we have A times B to the x power. So we know this is going to be x in that blank up there. The question is, what's going to go in these other 2 spots? I need something here, and I need something in those parentheses. Now we know from what our discussion before that A is the starting amount. So how much are we starting with? 15,000. What is our growth factor? Should I put a 3 in here? What would it mean if I put a 3 in there? That would be 300%. I mean, that college is swimming in students every single year. They cannot keep up. They cannot buy enough land for parking. Unless this is an online university, they cannot keep up that kind of growth. I mean, tripling your number of students every year, there wouldn't be enough space. Okay? So, I know that's not it. Would it be 1.3? No. What would it, what am I saying? What percentage did I just say it's going up by? That's a 30% increase. So you must be right when you said 1.03. And you are correct, because 103%, when you move that decimal over 2 places, would make that 1.03. Okay? Use your calculator right now and figure out after 23 years, how many students are there after 23 years? 23 years. Use the calculator and figure it out. Oh, use that machine. Have we reached 30,000 yet? Have we reached 30,000, which would double the size of the unit of the college? After 23 years, have we doubled? Yes or no? Have we doubled in size? No. 29,604 is not double 15,000. Okay? Right? It's close, yes. You?
Then you want to hit times. For you want to do parentheses. Now 1.03. And parentheses. Then you want to do the y to the x, or x to the y button. Now type your 23 equals 29,604.
You're going to have to be careful with that. Now, listen to me. If you're going to show me that kind of work right there, if I know what formula, and I know what you put, let's say you show me that you plug in 23 for x, is the truth that if we round up, we basically just created half a part of a person, right? Because technically it didn't actually get to 604. I'm not concerned about the rounding issue. If this kid rounds it to 603, and this kid rounds it to 604, as long as they're showing me what they're plugging in, I don't care. Now, for the kid who puts 29,603.7, that's just a sick kid. Really? Part of a person? Come on. Okay. But, as long as you're telling me, oh, for this one, x equals 23, if I can see something to that effect, then I don't care about the rounding issue. Okay. Write your next equation. Population 140,000 grows 3% for 15 years. Starts at 140,000 and grows at 3% for 15 years. So it's the same growth factor, 103. We started with 100%, 3%. So, where we want the 140,000 there, we have to figure out what goes in here. But it's the same exact strategy as this. So it's 1.3. 15 years. Calculator today? Yeah. I would make sure you use the parentheses when you're typing it through. Yes, perfect. So 140,000 times 1.03 to the 15th power gives me a population of what? Yep. 218,115. Yeah. Don't know what happened there, man. He just disappeared, yep. Dropped out of college. Oh, this wasn't college. Are you done with my calculator? Seriously? Walmart has them. Okay. Suppose. Whoa. Oh my goodness. Suppose we change question 12. Suppose we change it to a 2% decrease. You're still starting with 140,000, but we are going to decrease by 2% for 15 years. I want you to find a new equation and a new value for the 15 years. So we need to do this with a 2% loss, 2% decrease.
Wouldn't this be the answer?
So my new equation would be 140,000. What's the growth factor? If you're at 100% and you're going down 2%, 100 take away 2 is what? That's 98%. So what are you going to put in here for the B value? 0.98. 0.98. Now figure out with 15,000. Or, I'm sorry, not 15,000 years. Just 15 years, man. 15,000 years, I'm pretty sure they're all dead. Have we fallen below the 100,000 mark yet? No. Well, yeah, like 15,000 years, you know. Okay, so if the x value is 15, then we would get a population of what? 103,400.
You see it going around those. That's what I got.
Yes, rounding. We're just going to do standard conventional rounding rules, but I'm not gonna argue with a kid that put 399 there or another kid that put 400 there, as long as they're showing me what their equation is that they plugged in 15 for x. No big deal. Good. In fact, buy a couple. That way you have like a backup. Okay? Since 2006, the amount of money spent at restaurants in a certain country has increased at a rate of 6% each year. Okay, so we are increasing at 6% each year. What is the value of B? Can you tell me the value of B by looking at that, or do I need to draw the diagram? That is 1.06. Good. Okay. If that doesn't make sense to you, then kind of draw the diagram and say we're going up by 6%, so that would be 106%. Okay? In the year 2006, we have $340 billion that's spent. The one thing I don't want you to do is I don't want you to write out a bunch of zeros. I really want you to start with the number 340. So that means that my answer is already going to be in billions of dollars. Don't waste your time with a bunch of zeros. Okay? That's the same dating advice I would give you. All right, now, if we're starting in 2006 and we're ending in 2020, how many years is that?
14.
That's 14 years. So I'm expecting to see that you decided that there were 14 years, and you can now plug it into a calculator and make this the last question of your day. At least with me. 1 + 6 to the 14. How many billions of dollars do we have there? You quit already? You didn't even type it in. That's ridiculous. 769 billion. I don't care if a kid puts 768.7. The rounding issue to me isn't the big deal. Showing me the work, showing me what you plugged in, that's the big deal. And getting an answer that does round correctly is good too. All right, we will continue this next week.